Today's victim is a pair of Bluetooth headphones. No branding on it anywhere. Um, don't know how old they are. They do have a micro port, not C, but you can still buy things with micro on them. There is something rattling in it. So, yeah, we'll see what they look like on the inside and what. So it seems to me that a lot of things like this are where some usually Chinese OEM says, hey, let's make Bluetooth headphones. And then they come up with a few basic designs and go up on Alibaba and say, yep, Bluetooth headphones here. And then when somebody buys them, they can sell them as is. They can pay a little upcharge to have their own name on the packaging, a further upcharge for custom branding, and further yet if they want to have some other customizations on them. I don't know what the packaging for these said, lost to time, but let's see what the inside is. Did not bother checking to see what the advertised name of them is, but I'd be surprised if that was customized without even branding on the things themselves. I ate dinner. And no, I've not had these apart before, so this is going to be a first time. Let's see what this looks like. And I've got some basic covers over the end of the padding. That's actually stuck in place, and I might want to try reusing that thing for another pair of headphones that I like. Alright, what's next? Alright, these come out that direction. So a lot of headphones, there's sort of a stretchy thing that slides into a slot here. So these work that way. At least pads are not destroyed yet somehow. Just a thin piece of cloth here, and yeah, the stretchy thing that goes into the slot to hold the ear cups on. Wow. So you can probably see here, these are welded together, or welded shut. These are plastic rivets, not screws, which means these are not going back together. All right. All right, that side is just the speaker, and the thing that's rattling around is the spring for the adjuster here. That makes it seem so fancy. All right, the cord is a pretty typical one, where you have strands of enameled copper wrapped around some sort of poly string, which is the actual strength thing on it. The poly string is what holds the wire together, and it does go back together. They're just press fit. Why am I not surprised? I shouldn't be surprised by that. Sometimes headphones will put all the electronics on one side and the battery on the other, but not the case here. All right, that came apart. There's that speaker. There's a very puffy lithium battery. And a tiny circuit board here with a few solder pads. Well, that battery is going to need to be disposed of properly. Let's see if there's anything to look at all on this circuit board. battery's making me nervous. I'm going to cut her off. And remember, when lithium batteries, only cut one wire at a time because you do not want to cross the wires. Alright, so this board, we don't have an epoxy blob. Yay. It is a single chip. It says not enough light and too much glare on the microscope. Let's try this again. A lot of times, light from the side is very helpful for reading things like this. There's the right angle. AS208 P027402504. Look again. AS. Try and get a better picture of this to insert. AS208 P02740. I do see one little microphone on the board there too. Typical PCB trace Bluetooth antenna right behind the audio in jack. USB port has, I believe, nothing going to the data lines. I think it's just for charging. Yep. No data there, just charging. And, well, it says Q1, maybe. Alright, that must be actually a transistor, not just a diode for a... Oh! Okay. Yep, I know what that is. Alright, so there's a rather cute little way of doing a half-ideal diode. Wait, what? So there are two little vias labeled DM and D. The data is hooked up. Huh. Maybe this thing does do USB audio as well. Alright, Google AS208 P 02740 dash 2504. Nothing there. I'll try a little bit less. FA inquiry, nope. Alright, I may have found at least the manufacturer of that chip. Joagili. Search for AS. 08P027. No publicly available data sheet on that, so yeah, not a whole lot to see here. The basic components are a couple LEDs of different colors, a few switches that are actually labeled, power and pairing, volume plus, volume minus, B plus, B minus, L minus, R minus. So it does look like there's at least a 3-channel amplifier in there for a virtual ground. So yeah, not a whole lot to see here. I will go find a marker though and kind of sketch out what I mentioned earlier about a not quite ideal diode circuit. Alright, so the way that one of these not quite ideal diodes typically work is, let's say you've got a battery, single cell lithium, whatever, and if you have just a diode going into your circuit, whatever it is, and you've got the voltage drop across that diode, which is less than ideal. That can reduce the available power for your circuit by quite a lot. So the better option is a FET. The way you'll oftentimes see this is you'll see a P-channel FET with the source to the battery, and the result of that is that even when the FET is off, this still acts like a basic, P-channel is the other way. The source over here, so let's put this at ground and see what happens. If this is at ground, then you've got positive coming in, that diode begins to pull this rail up a bit, and once that is somewhat up, then you have the voltage between here and here to turn on hard, and you wind up with a direct short all the way through, so you get from your battery that can be from 3.3 to 4.2 direct straight over here with no loss, because that's a resistive junction, not a diode junction. So what you'll oftentimes do is, let's say you've got a USB port over here. I'll draw type C sort of, ground obviously. Got 4 of those, plus you've got 4 V-bus lines, and if you run that over to the gate of your thing, throw a little resistor on here, it can be like a meg or something, doesn't really matter. Then when there's nothing plugged in here, this resistor pulls that back down to ground and turns on that FET transistor. But if you do have 5 volts over here, then this will get high enough to turn off the transistor, and because you've got a diode, and you can just use a plain diode here, now you have this diode forward bias taking the power from the USB port, 5 volts from the USB port. This inherent diode here is reverse bias, so there's no current flow there, and now you have 5 minus 0.3 volts, which is about what you get from a silicon diode, and you get 4.6, 4.7 volts there, which is still plenty to run a lithium battery charger. And then if you're running a lithium battery charger off of this and it's trying to charge this battery, well, you just have the quiescent current there, which a lot of times isn't very much at all. So even if you don't have power coming in and you do have that, when you have the input and the output of the battery charger tied together, the result is basically nothing. So yeah, makes a lot pretty easy. I guess post up below if you have any other questions, and I'll either try to answer them I'll try to answer in the comments, or we'll see what else happens. Thank you all for joining me. Have a good one.